Can you hear me now better? All right, perfect. So I wanted to encourage you to experiment with those Pierce's disease resistant varieties because you have the perfect region for it because you're dealing with the glassy wing sharpshooter and the need to put on these systemic insecticides. Remember, those insecticides go into the juice and into the wine. So anything you can do to reduce that need, I think, is in your favor. And I think you guys can market that stuff effectively. But here today, I'm going to talk about climate change impacts to vineyards. I know you want us to go a little quicker. Okay. So I heard the discussion about the weather stations you have here and elsewhere. That's great. That's some really good data, and that over time you can collect some good information with that. If you want to do it on the cheap, there's another way I do with these small data loggers, little hobos. And this is an example of the kind of data you would collect on temperature in a vineyard. This is from a site in my area where they were considering planting grapes. They wanted some background on the temperature conditions so they could know what varieties to plant, for example. So what we did, put the data logger out. We're looking at temperature data collected every 15 minutes from April 1st until October 31st. That's our standard year for our growing season for grapes. We sometimes adjust that in different areas. So that's what that black squiggly line is. Well, it's kind of hard to make sense out of that data, so we summarize it into very simple numbers. The two that we typically use are just an average of all of that temperature data over that 7-month period, that's the red line there, or the growing degree days calculated over that same time period. And that's what that blue line is representing with the scale on the right-hand side there. So average temperature over the growing season, degree days over the growing season, they really tell you kind of the same thing in the manner that I'm talking about here. Okay, next. How do you use that data? Well, the left-hand chart there, which I know you can't read, the text is too small, but that's categories based on degree days of growing conditions, the different regions. So we've used this classification for decades, and we know in different areas of the world what types of varieties correspond to the different degree day values. On the right-hand side, maybe you can see that a little bit better. That's based on average temperature. This is a diagram that Greg Jones put together. He's broken it down to different grape varieties and where they fit with the average temperature during the growing season. So very simple way to see, as temperatures get warmer during the growing season, that changes what varieties are most suitable for that condition. And as it gets really hot, you really get out of the range of quality wine production. You can kind of see you get up to table grapes and raisins here on that right-hand chart there. So again, the take-home message is, grapes are influenced by temperature, the selection of variety clearly driven by the temperature conditions. Okay. Now, the concern that we're starting to have are these heat spikes as well. So shorter periods, very high temperatures. Again, I forget, this was 2017, I took that data. So this was actually kind of a semi-coastal area, but we got up to 110 or more degrees in that area. And those are the kinds of things that are now becoming really challenging for growing grapes. We can actually handle the consistently warm temperatures just fine. You get these spikes, that's hitting them hard. Especially when you have exposed fruit, they really bake. So that is becoming more of the concern now, not really the average temperature, it's these spikes. Okay, next. And so there's a tool that we can use, this CalAdapt.org website. If you go to that, find your location, you can now look at what the predictions for how these temperature spikes are going to be changing over time here. So what this chart is showing you is now 2020 is right in the center, basically, of that chart. So all of those spikes on the right-hand side, that's the predicted frequency of these heat events. So just because of climate change, the prediction is, in this example for 110 degrees or more in Paso Robles, we're expecting far more of these heat events to happen. So we need to learn to manage around that. How can we protect the grapes to not have them be damaged by these, what used to be very occasional events, now are going to become more routine. Next, please. That was one scenario for sort of what we call the low carbon dioxide emission scenario or greenhouse gas scenario. This is the higher emission scenario. It's hard for you to read the numbers, but this is predicting more of these heat events happening. So again, we're just going to have to learn to deal with this. Okay, next. Hard to see that, but here, let me vividly describe to you what's going on here. This was a picture I took in June. This was the variety Nebbiolo. We had a heat event in Paso Robles, and all of the flower clusters on these vines burned off. clearly a really good and sad example of how temperatures and temperature extremes impact varieties. And this is the kind of thing that you guys want to know before you plant 60 acres of Nebbiolo here and then find out 4 years later that you can't make fruit from it. So this is really important information to have. And that's why we do these trials on smaller scale with different varieties to see what fits. This is an example of the heat impacting fruit. When we have, especially our VSP systems, the fruit is exposed, oftentimes on the warm side. Heat events, that temperature of the fruit rises. We get sunburn, bleaching, raisening of the fruit, all things that degrade the quality for producing wine. So this is what we need now to maybe rethink how we're training and growing our vines to prepare them better to hold up against the heat. Okay. So what is happening all throughout California and the world really is changes in canopy management. So going from those straight up and down VSP systems where all the foliage is tucked vertically and does not provide very much shading for the fruit into systems like on the left, that's a hybrid system where the shoots are positioned on the cool side, the shady side of the canopy, but they're allowed to flop out on the sunny side. So you get some protection from the sun by doing that. And then the right picture is showing you more of a full sprawl. So now we get this maximum amount of shading possible for the fruit. So this trend, it isn't just happening in places that we think of as being warm like Paso Robles, it's happening in places like the Napa Valley, where they as well are seeing problems with these heat spikes up there and having to manage around that. So this is one of the basic tools that we have to do that. Now, one thing to keep in mind, the larger the exposed canopy you create, the larger the water requirement for that vine. So we have to shift a little bit more towards thinking of these as crops that are not quite as stingy with the amount of water we give them. We need to give them a little bit more to grow this protective shading for the fruit. So that is, I think, a trend we're going to see a lot more. Okay, next. Shade cloth. If you don't want to grow those larger vines and want to spend the time and money, you can put out shade cloth and get really very similar effects by doing so. It often just boils down to the cost. Is that something to have to deal with? You put it out and have to remove it every year, but it can work quite well. Okay, next. Overhead sprinklers, another very effective tool for lowering temperatures during these heat spikes. Now the question is, do you have enough water to do that? It often requires a second irrigation system because your drip irrigation lines won't have the flow capacity to meet the requirements for putting on sprinkler over the entire canopy like that. If you have poor water quality, this can have problems with toxicity issues with the foliage sometimes, so you wouldn't want to do this without having done a lot of research on it. For most of us, though, the requirement to have a large amount of water available is the big limitation to be able to do this. But I think we're going to be seeing more of this being done. Okay, next. Hard to see this. This is a kaolin clay. The trade name is Surround. It's a natural clay product. Mix it with water, spray it on the vines. Basically, it's a whitewash. Does anybody here use this at all?
Use it on the olive trees.
Yeah, perfect. So you have examples here. So. Yeah, it can lower the temperatures within the canopy. Definitely can be part of your stress management program here. It also can help keep pests off like leafhoppers. So if you're having problems with leafhoppers, this can be a tool that you use, and it's organically approved as well. Okay, next. When we talk about temperatures, one thing, it's an important concept to keep in mind that temperature varies with distance from the ground, okay? In the middle of the day, the air temperature is much hotter closer to the ground than it is at some height above the ground. And this is one of the tools that I use to measure that relationship. Okay, next. So this is a chart just showing you, this is some springtime temperature data at a site in Santa Barbara County. So my original interest in taking these measurements was to deal with frost conditions. Okay, on a cold night, the air temperature is much colder near the ground. And that's what we're seeing here on the left and the right side. That's the nighttime temperatures. That solid black line, that's the air temperature at 1 foot above the ground surface. The blue lines, that's 7 and 8 feet above the ground surface. So you can see there's a stratification of temperatures that occur on nights when there's no wind and the skies are clear. So from a frost protection standpoint, it's advantageous to have the vine sensitive tissues higher above the ground. If you train your vine at 1.5 feet above the ground, that's going to be very prone to suffering frost damage. But conversely, during the daytime, you see the peak of that, the air temperature is quite a bit warmer near the ground. So if we're trying to avoid peak summer temperatures in July and August, having our vines raised higher above the ground can be a strategy to avoid those high temperatures. Okay, next. And it also influences the growing degree days. Okay, so here I just calculated for one of these sites the seasonal growing degree days at the different heights above the ground, and I had to kind of cut the scale, but I think you can see at the top there, each vertical line 100, so 1, 2, 3, over 400 growing degrees difference from 1 foot to 8 foot. So that's a big change in growing degrees over the season, just by fairly short distance and height above the ground. Okay, next. And then lastly, as I mentioned, choosing that height, that where you put the sensitive tissues of your vines, can be one of the key things that's part of your management decisions that you make. It's a very flexible plant. So that vineyard on the left, that's me. I look like a giant there, but what happened, this owner had traveled to France, I think, and got inspired with these tiny little vines and said, oh, I want to do that in California. Created a big problem for themselves from a frost standpoint. Okay, so that's why I was out there kind of measuring what they were doing here. On the right, that's a gentleman in Argentina. Those vines, wine grapes, they often grow in these overhead trellis systems. Part of the reason for that could be because now that fruit is 7 feet above the ground and it's very well shaded. So you get really comfortable temperature conditions even on a very hot day underneath that canopy. So I'm not saying we can go do that here, but kind of keep those concepts in mind that we can modify the climate by just how we choose to grow the crop itself. Okay, so that's all I've got for you. Any questions or comments?